Hello and welcome to our Climate Contraptions activity for Zero Cambridge. My name is Alison and I'm the Learning Coordinator at the Whipple Museum for the History of Science. I'd love to be welcoming you to the museum, but of course that's not possible at the moment. This short film will introduce you to 3 of the objects in the collection which were used to measure aspects of the weather and challenge you to create your own weather measuring device. We're going to start our mini tour with an object which is on display in our exhibition to celebrate the 75th anniversary of the founding of the Whipple Museum. So here we are in the gallery, and this is the object I want to tell you about. This huge barometer was made between 1775 and 1800, and it measured air pressure and temperature to tell its owner what the weather was like. As we move down the barometer, we can see that it was made by Nairn and Blunt of London, and we can see different weather conditions from stormy to very dry. Now it's always stuck on rain. Further down we have the thermometer, which shows fever heat at 112 Fahrenheit, blood heat at 98, sun heat at 76, temperate at 50 and freezing at 32. It works by using the fact that increasing heat expands the mercury, which would have been held in the bulb at the very bottom of the thermometer here. The barometer and thermometer would have been a very important way of telling what the weather was like, and of course if you record those measurements over time, then you have an idea of how things are changing. It's also a very beautiful object and shows that someone thought it was very important to have it in their house. Our next 2 objects aren't on display. One of the good things about doing tours in a virtual way like this is that it means I can use many more objects from our stores. The first object from the stores that I'd like to show you is this Campbell Stoke sunshine recorder, which was invented by John Francis Campbell in 1853 and then changed by Sir George Gabriel Stokes in 1879. The sun shines through the glass ball and is focused onto whatever is behind it, leaving a burn mark. As the Earth turns, the light is focused on different areas behind the ball to leave a line which shows how much of a day had bright sunshine. Originally, the outside would have been a wooden bowl, and the burn would have marked the bowl itself. The change that Stokes made was to make the outside out of metal and use paper inserts to record the sunshine on different days. It's a very useful piece of equipment because it has no moving parts and doesn't require any power except for the light of the sun. Our final object is this beautiful French hygrometer, a device for measuring the amount of water vapour in the air, in the shape of a tower. The 4 windows and the doorway are left open so that air can get into the tower and be measured by the hygrometer. The tower is hollow and contains a cylinder with paper words and figures on it. Inside the tower there is a hygrometer element, probably a human or animal hair, which changes length and moves the cylinder around to show different words and figures depending on the weather. You can see here that there is a man and the word pluie to show that it's raining, and if it was fine, we would see a lady and the word beau. I don't know why all of our weather measuring devices seem to be set to rain. Maybe we just had a very pessimistic curator when things were coming in. Although this is designed as an ornament, it also provides important evidence about the weather, and if you kept records of the changes in humidity over time, then you would have valuable information to find out how the climate is changing. Now that we've looked at 3 devices for measuring the weather, we'd like to challenge you to create your own climate contraptions. Can you design or make something which can measure something about the weather? You will need to think about what you are going to measure, how you can measure it, and how to record your results. You'll also need to make sure that your measuring device doesn't have too much of an impact on the environment itself. Could you make it out of recycled materials? Could you make sure it doesn't need power, except from renewable sources? We'd love to see your designs if you're happy to share them. You can send them to me at whipplelearning@gmail.com and we'll share them via our website and social media. Many thanks for joining us.